we are. And I just really, I'd like to just really put a note of appreciation as well out to everyone that's joined today. This event is really, you might say, what's leading in the industry of sustainable design, sustainable infrastructure, and really becoming the green citizen. And here we are at 2020. We've got some, you might say, unrivaled challenges over this past year. We've got some interesting, you might say, areas that we work within and spaces that we work within. But what I'd like to really highlight today is how we can invest and really understand some of those challenges and how we can work within them at the same time. So with that, I'm going to also maybe have to break out my screen. I've got some audio and visuals that I'm going to be playing as well. I like to engage in that aspect. Just a bit of background here. As a company, as a global company, our mission is to enable sustainable cities through green and blue infrastructure. So we want to really understand that. We want to really understand what that is. And what that brings together is all the different disciplines. It's you as a person. It might be the landscape architect. It might be the pedestrian. It might be the contractor. It might be the municipality. It might be the federal government. It might be companies like TD that are actually making the changes in the environment. And we want to look at this. This is a holistic approach. This is the vision of interdisciplinary collaboration. So some of these slides I'm going to go through fairly quickly, but I want to really highlight something here. And this beautiful image before us, we all can see this acorn. You might say that it's the kernel, it's the nut, it's the thought of where we are. I just want everybody on this call today to remember this image and the statement here and the question, what did I grow from? We're going to come back to this at the very end of the presentation, but we want to understand this. What are the challenges and what did I grow from? And this really takes us forward into understanding and establishing the actual future of the urban landscape. So we start understanding what the values are. We start understanding what the challenges are. We start understanding how we can really work around these challenges and invest in the future in these spaces. And with that, we need to really understand why. So I want to move forward here and really start to, you might say, dig deep and try to work within these challenges. I'll just move and advance this screen here. I apologize, it's a bit slow. There we are. Let me just back up. So we want to look at below the hardscape as well. So we can always visually walk down the streetscape. We can actually look at these urban areas. We can look at what we see in this visual in front of us here. But what we want to do is take this a step further. And what I'd like to do is I'd like to introduce one of my colleagues, Mr. Howard Gray, and he's going to give a little bit of a understanding on how we can meet these and some of the actual challenges we provide. I'm just going to unshare my screen for a moment and reshare it, and then we'll get this started.
Yeah, let me know if you have any issues sharing the file.
Yep, thank you, Andrew. Just a second. Okay. Looks like the tab I had before, Andrew, isn't there anymore. Maybe this video won't share then.
Do you know if it's an MP4 file, it should. If you go to Share, File, and then navigate your computer and find the file, it should be able to go.
Okay, that's all right. Okay. Does that come through, Andrew?
I think you might be sharing the application, so there's no audio.
Okay, just a second.
Do you have an MP4 file specifically?
Yeah, it is an MP4 file. I just want to. It's there we are. Let's try this.
No, WebEx is not the most the nicest platform for sharing content.
No.
Which is probably why we'll go to Zoom next year. So.
Yeah, I apologize for this.
Not a problem. We'll figure it out.
I was just I thought joining with WebEx themselves would give me a hand. They would support in this, but it doesn't look like it quite works that way with the different files. So that's all right. There's
well, potentially, I guess we could just move on then.
Yeah, I think we'll just move on. I apologize for that. Let's just move that on. And we will just go to slideshow and from current slide. Just loading there again. Some challenge right here. That's all right. We'll get going. Skip this here. There we are. Is that presenting now, Andrew? Yep. Okay. So just continue on here. We want to understand some of the challenges that we face, and that was some of the information there that was being shown in the last slide, but that's okay. We'll move on from that. And some of the challenges that we face in the urban environment are things like the heat island effect. And the challenges with the heat island effect are really understanding the difference between where we see areas like rural areas where there's limited or no, you might say, heat island effect, and areas within our urban spaces in our cities where we have massive amounts of heat absorption and retention of heat. And the difference in these areas is actually between 3 to 10 degrees Celsius in increased heat in these spaces. And what we want to really understand here is how we can actually change this. So with these spaces, what we start understanding is if we start increasing the sustainability factors and we start increasing the value of what we're putting into our environments, we really start recognizing and understanding how we can reduce the heat island effect. The other areas that we see is applications like increased urbanization. Now, increased urbanization, of course, can be something that can be somewhat mitigated or challenged within our spaces. What we want to see here is how we can reduce the levels of hardscape that are not infiltrating into the groundwater spaces. So if we look at that, as we increase an urbanization, we start increasing hardscape. And the challenge with hardscape is it in turn increases water runoff. So we want to look at how we actually mitigate this and reduce these challenges. Now, it's interesting because we talk about 100-year storms when we're working with engineers. We talk about 50-year storms when we talk with engineers. But one of the challenges that we do see is that 100-year storms are actually turning into about 7-year storms. So extreme storm events have increased drastically, and extended periods of rainfall are now 7 times more likely in these areas. So this is a massive challenge. We've increased urbanization, we've increased hardscape, and we've increased the extended periods of rainfall in these same zones. So we want to really understand these challenges and make sure that they're functioning within the spaces that we provide. Now, as we start doing that, we start seeing the strain on our stormwater and sewage systems. Now, I'm just going to break my screen here quickly and then reshare it. Just a second. There we go. Perfect. And one of the challenges with strain on existing stormwater sewage systems is that it causes flooding. And we know in the city of Toronto, for instance, we had that flood a few years back, causing collateral damage, causing massive damage, causing infrastructure damage within these same spaces. And we may say, well, this is far away. One of my colleagues in the United States happened to send me a picture just a couple weeks ago of a condition in Knoxville, Tennessee. And I just thought I'd show these images. So this is an actual storm event last year that happened in Knoxville, Tennessee. We can see there on the left-hand side where this fire truck is actually fallen off the curb. We can see the significant amount of flooding, and we can see these challenges. This is a reality, folks. So we need to understand what's actually happening and how we make these changes. Now, with that increased loading on streams and rivers, we also look at the actual challenges with biodiversity. So the effect of increased nutrient loads is another challenge we face. So algae blossom, as we see in that red circle in that river. And on the right-hand side there, we can actually see that same river after a rainfall event and flooding. So it increases nutrient loads, increases temperatures of stormwater, increases hydrocarbons, and of course that damages the ecological systems and habitats. So when we look at that, we want to understand how we can make these changes. We're going to invest in this. We're going to look at what the investment actually is. Now, we also want to look at the reality side. So we look at this, as we call it, the LID challenges, the low impact development challenges, and we look at the maintenance that comes with them. There's something that happens regularly in the climate that we live in here in Ontario, and that's called snowfall. It's something that's coming very shortly from what I hear as well. So we want to understand that if we're going to provide something like a rain garden, like we see here in the left-hand image, a beautiful rain garden, this is actually in Grand Rapids, Michigan. We look at how its functionality is, we look at the challenges, but sometimes we forget about the maintenance that comes along with it. We look at this right-hand image here, and we see that very same bioswale that hasn't been maintained, and there's nothing left inside it. So we want to make sure if we're investing in the future, just like we're considering here today, if we're creating sustainable infrastructure, if we're creating sustainable development, we need to look at the maintenance and the challenges that come along with it. Now, we'll just look at some standard options to mitigate these challenges. This is the everyday occurrence. So we might look at something like an attenuation basin or a storm pond. Now, these can be quite interesting, quite beautiful, can be something like a park. But we need to look and understand at what the liability might come and who actually owns this space. Now, this project that we see in front of us here is actually over in the UK. So we're actually going to go around the world here. We're not just going to sit in our chairs and in your desk. We're actually going to go to different spaces around the world. But the challenge with this project here is who takes ownership of this, who maintains it. And if there is a challenge with it, who takes ownership for the liability. So that's one condition we need to look at. We might look at something like a swale, like we see here. Now, swales take up space. They also have some liability challenges, but they can be functional and they can work within certain criteria. We might look at some interesting application like a storm pond, like we see in this image that we see here. Challenge with storm ponds is they are filled with water. They can be what we call a mosquito infestation pond. So we don't want to always look at just the simplest application. When we're creating sustainable infrastructure, we want to look at how this functions within the surrounding spaces. We want to recover, we want to renew, we want to reshape, we want to really understand not just today, but in the future. Now, with increased urbanization, we also look at applications like the heat island effect. And I thought I'd just show this interesting image here. We can take simple factors and reduce the heat island effect, such as a vegetated paving surface. Now, on the left-hand image there, we can actually see the result of this test of a concrete surface over to, on the right-hand side of that image, to a vegetated surface. And we look at the difference in temperature differential on the top left corner to the bottom right corner. And all this is a grassed area. So when we look at this space, we can also understand what we want to create. So we look at the importance of biodiversity. We look at the importance of low-impact development. We look at the importance of sustainable infrastructure. We also look at the importance of pulling these spaces to create one space. Now, people will ask me the question, why should we use a tree for low-impact development, for LID? What does this actually mean? We actually bring it into the 4 pillars. We look at what those pillars actually mean. So we look at water quality, the investment of it, how we control it, and how we control runoff. We look at water quantity. We look at how we can reduce pollution and volumes. We look at amenity space, how we create and sustain better places for people. That's us. We look at biodiversity, creating and sustaining better places for ourselves and nature. And somebody told me once, as we look after nature, we look after ourselves. And this is critical. So we start understanding really what a tree can do for us. We look at it as what we call a high-performance tree. Now, the tree in itself might have the benefits of transpiration, canopy interception, reduced throughfall, increased infiltration, phytoremediation. There's all these different benefits that come along with the tree in itself. But we want to look outside of that scope and really understand what it does for us. And we look at that, we look at what we see here. So we get what we call the total value. So a 10% increase in trees can postpone health problems by 5 years. These are research facts. Students with a view of trees recover and pay attention longer. Isn't that a fantastic thought process? We can actually be more focused. A 10% increase in tree canopy has been associated with a 12% decrease in crime. Whoever thought that trees prevented crime? Particulate levels in tree-lined streets are up to 60% lower than those without trees. So the air pollution has been reduced. Trees, of course, provide food and protection. They increase property prices, and the list goes on and on. So we're going to look at these values individually. What we also want to do is look below ground. And this is one of the images I really love when we actually take a tree and we break it down and show it in its, you might say, its physical parts. We see the tree canopy. Below that, we have a trunk system, and then we have what's below ground, what we don't see, which is the root system. And the root system is just as critical, if not more critical, than what we see above ground. Now, on the left-hand side there, we see these little fine root hairs and a pen. You can start understanding how small these root hairs are. These root hairs actually create the value and the benefits for these trees. These are what take up the stormwater. So it's incredibly important that we create the spaces for these. Now, if we just take a simple value, 100 gallons of stormwater, so that's like 2 55-gallon drums, or almost 400 liters of stormwater, are absorbed every day through a single tree. That's on the low end of the scale. Some of these sequoia trees in our natural forests can take over 1,000 gallons of stormwater per day. So if you start lining trees up in streets and utilizing them for stormwater management, we start understanding the benefits that we can actually provide. Now, this means providing infrastructure for them. I want to highlight here, sometimes on the surface we just see this 1.2 meter by 1.2 meter square tree grate. That's not what's happening below ground. Or we might see this little planter opening, but that's not what's happening below ground. City of Toronto has many guidelines that require infrastructure and support for trees. And we're going to look at some of these. But what's actually happening below ground is what we see in this image right here. And this image right here, we see infrastructure that's provided for these trees. So we can attenuate stormwater. We can hold that stormwater and utilize it for growing trees. We can filtrate through pervious surfaces, so that's just pervious pavement, pervious concrete, pervious asphalt. We can bring in stormwater from curb inlets or linear drains and utilize this tree as a high-performance tree. So when we do that, we want to understand how we better utilize trees for these aspects. So urban trees are an overlooked asset in stormwater management. That is a fact. Yes, it's a question, but it's also a fact. What other asset, if we just sit back and think about this for a minute, what other asset in our urban spaces increases in value over time? And we think about this, curbs, they don't. Sidewalks, they don't. Roadways, they don't. Sign poles, they don't. Lights, they don't. Pedestrians, they typically do. Buildings, they increase in value, but do they increase as an asset? What about a tree as an individual living item? It increases exponentially in its asset value over time. So then we start understanding how we utilize trees for BMPs. So as a BMP, as a best management practice. And the challenge is, how do we value a best management practice and what does this actually mean? And I'll just make a note here. I hear a lot of words about best management practices. The challenge is, let's make sure these best management practices actually work. So with that, we look at some of the values. So if we increase the tree canopy by just 5%, we can reduce stormwater runoff by 2%, just by increasing the canopy. Now we know, as a factor, that large trees provide exponentially more benefits than small trees. Now we can see these two beautiful trees in this picture from the top. But sadly, we know that large trees are not often found in urban areas. And we look at that. Now we're planting trees as an investment. And if we're going to invest as ourselves in the value of something for ourselves, we typically want it to be long-lasting. So if we're going to invest in a car, if we're going to invest in a house, if we're going to invest in an object, we want it to be long-lasting. But I'm just going to give you a very true but sad factor here. The average lifespan of a tree in an urban environment is only between 3 to 13 years. And I get many people that come to me and say, but trees last for 50 years or 100 years. But in an urban environment where thousands and millions of people are, the average lifespan of this asset that we've planted is between 3 to 13 years. It's not very long. And why is that? I'm going to show you an image here that I love. It's one of my most favorite images, and that's because of education. And this is the key of education. And what we see here is a very simple, you might say almost childlike or preschool application where we can really understand how stormwater functions with trees. So we can see where the water comes in on the right-hand side there. It flows through the tree planting zone. We can see it where it says grow. So we're watering these trees utilizing stormwater management. We can see how it flows through the system. An extremely simple yet beneficial way of helping pedestrians understand what trees are doing in our environments as assets from the top surface. So we want to just understand, when we talk about trees, what the asset value is and how they actually function. So as you move through your educational career, as you move through your lifespan as a career, we want to understand these spaces because we're in them all the time. Now, we see some smaller trees in this image, but I'd like to highlight the difference between a small tree and a large tree. So we just take 1 inch or 25 millimeters of rainfall event, and we take a 2-inch or 50 millimeter caliper, so a 50 millimeter diameter tree. The absorption of canopy interception is about 15.9%. If we take that same tree and we increase it to a 22-inch or 550 millimeter diameter tree, so what we call as a stabilized tree, the canopy interception is at almost 80%. So by growing large trees, we start understanding the value of this asset in our area of infrastructure. It's not about just replanting trees every 3 to 13 years. Now, with the ultimate low-impact development tree pit design package, you want to make sure there's some criteria met. You want to make sure it's sustainable and effective and environmentally robust. We don't want to put something in the ground today and then 5 years down the road it doesn't work. We want to make sure it reduces the velocity and flow rates of runoff from these areas. We want to make sure it meets discharge rates. There's very key areas that we work within to make sure these systems actually work, because that's part of the best management practice. Now, I just want to show you a very simple project that was done well over 10 years ago that actually was spearheading the design of these systems. And this is a project over in the UK at Dundee University, and they call it SuDS. SuDS stands for Sustainable Urban Design within a tree pit. So we're going to take a fairly small amount of soil volume. It's just over 13 cubic meters of soil volume for this tree. And we're going to see if we can provide a minimum attenuation, so attenuation being that the soil holds the water like a sponge, of 3,850 liters of water. So a substantial amount of water. We're going to see if we can reduce the flow rates of the outflow from this catchment area. Now you can see that gentleman in the picture holding that tree. It's about a 2-inch caliper tree, a 50-millimeter caliper tree, a fairly small tree. Now let's just jump ahead and here look at some of the values. The results measured a demonstrated value of reduction in outflow by 88% with a lag time of 45 minutes between inflow and initial outflow comparison. So what's that saying is, if we have a rainfall event at 2 o'clock, it wasn't until 45 minutes later that there was water coming out the base of this. So we can reduce the buffer, we can reduce the pressure and loading on our storm sewers and our sewage treatment plants. And then we look at the other values that come along with this. The total suspended solids, so this is the waste that we see on the top surface in this sense, was reduced by 50%. So this is less pollution going into the storm sewer. The phosphate, zinc, and lead were reduced by 70%. The nitrogen, copper were reduced by approximately 50%, and so on. So we're reducing hydrocarbons as well within this space. Now what I'd really like to show you is what the tree looks like 10 years later. So here's our tree in the same space, performing as a high-performance tree, reducing stormwater, reducing loading on the storm system, increasing the values as a high-performance tree. It's providing shade, it's providing value, it's providing amenity space, and it's growing as a living asset in our space. So what I'd like to also do is to help you understand how we could design some of these spaces. So I'd like to go through a very simple project where we remove microplastics. So below ground, we put in an infrastructure system supporting the root growth, what we classify as a soil cell in this application here, and ran the water through it. 98% removal of plastics happened on this project. Now here we have the actual project from the surface. And people say to me, oh, Jeremy, you're saving the whales, you're saving the oceans. Yes, we are. We're reducing plastic, we're reducing microplastics, but we're also creating spaces above ground for healthy habitat of pedestrians and animals. On top of this, the water savings for this city was over $750,000 per year in pumping costs. So that was the reduced loading on the storm sewer. Now we look at the value here as well, and we got 14% immediate rise in house values once the project was completed. So there's a balance to the owners and the pedestrians and the actual economy within that space. When we revitalize a streetscape and we put in green infrastructure as well as including blue infrastructure with that, we get the value of increased residential house prices. 14% on a home over a period of a year is an incredible, valuable aspect in that space. Now just looking forward, this isn't just about residential. Here's a project here, which is a very simplistic project. We can see there's 3 trees in front of this building, and we can just see around the squares below the tree, we can see some gray area, especially in the first tree there, and that's what we classify as a linear drain. What we're doing is we're sloping the direction of the surface into the tree planting zone to allow for stormwater infiltration. What we can't see here is what's actually below ground. And what I'd like to do is I'd like to show you what's actually happening below ground. So below ground, we actually have a full infrastructure system here supporting the growth of these trees, but also reducing the stormwater runoff. So this is what is called the ArborFlow system for managing stormwater runoff. Step 1 is the water flows into the storm inlet, which can come in different configurations. Step 2, the debris is filtered out, so that could be our total suspended solids as well as larger debris. Step 3, the water flows through the system and is vented. And step 4, the water enters the system and is then percolating into the root system. Now, I'd just like to show you how this actually works below ground. Now, I'm just going to see if this slideshow works here. Okay, I'll do it verbally instead of the video. That's okay. So what we have here is a permeable surface. You can see it's raining in this application. We've done a cutaway of the root space system below ground. So there's different ways of bringing stormwater in. We can do number 1. We can bring it in through a pervious surface, which is a great way of infiltrating and maximizing stormwater in the exact space that the rainwater falls. Number 2, we can use linear drain on the back of the curb around the tree planting zone to allow for infiltration within those same planting zones. Number 3, we can bring it in from a curb inlet, which is becoming very, very popular within these same spaces. Or number 4, we could bring it in through an area drain and infiltrate into the tree planting zone. The key thing here is we provide the infrastructure below ground to create this sustainable environment. Now, with that environment, we want to create the sustainable tree. And this is a project over in Europe. I thought I'd just show you this image because I think it's a great image to say a picture is worth 1,000 words. So we see this tree. Now this tree is not very old. It's only about 11 years old. We see nothing below ground. We don't see the infrastructure that's been provided for this tree. But this tree has about approximately 30 cubic meters or 1,000 cubic feet of soil below the hardscape to allow for infiltration. We can see below the tree's canopy that there's a round, dry area. So this isn't just about providing soil volume for the tree. This is about canopy interception. This is about noise abatement. This is about wind deflection. This is about habitat. This is about humanity. We notice these two people below the canopy of the tree on the bench. Are they sitting under the tree just because it's sunny outside? No, this is a picture in Europe. It's quite dull and dreary, actually. They're sitting below the canopy of the tree because they don't want to get wet. We can see this round circle of dry area to help us understand how canopy interception actually works with the tree. So moving forward, we can also use other aspects. So I don't want to just highlight it to trees. We can also use something like hydroplanters or rain gardens. We're actually infiltrating at ground level. Now we talk about the application of diversity. We talk about recycled content. We talk about the right tree in the right place. But we want to also understand how we use the application of recycled components. So when we look at this, we want to make sure that we're using recycled components in the right way. And being able to remove millions and millions of pounds of plastics from landfill sites and reuse them in green infrastructure and blue infrastructure applications is part of the circular economy of bringing these spaces together. So we want to understand when we create these spaces, are we using products like concrete that have very high footprint of carbon footprint? Are we looking at reducing carbon footprint? Are we looking at what sustainable infrastructure actually means? So when we look at that, we look at the spaces like we see here with a bioswale and rain garden. Two different spaces, two different applications. One's in a pedestrian area next to a sidewalk, the other's in a pedestrian area next to a roadway. We can see they're both functioning extremely well and creating those spaces for biodiversity and stormwater infiltration. These are a great way of reducing stormwater at the source and also removing pollutants and reducing the buffer, increasing the buffer on the storm system. Another way of doing this is actually through GreenWall Systems. Now, GreenWall Systems have been used in the past. Of course, we're in a climate here in Ontario that GreenWall Systems mostly function during the spring and summer and sometimes fall months, but not in the winter. So designing these, again, is very key to the right GreenWall system in the right space. But we can enhance the look of building facades. We can combat air pollution. And we can also reduce the heat island effect and help offset buildings for carbon footprint. This project was just completed at the Dallas Holocaust Museum in Texas. As we can see there, the green wall's just started in the background. It's allowing for some water infiltration at the same time. So when we look at existing spaces, we can look at how we can make these same changes. This is a project here in Virginia. What we did here is we looked at their parking spaces. We looked at how we could create some sustainable designs with tree planting. The design need system is very, very important, folks. I just want to highlight that and reinforce it again. The design need systems is very, very important. We want to make sure that when we create sustainable infrastructure and invest in it, it's working for years and years to come, not just for maybe the first 5 to 6 years or 7 years. So designing a system is very critical, understanding the requirements, understanding what our vision is, and actually creating these spaces. And that's what happened here at this project at the AFCE headquarters in Virginia. So we also look at how we get water into the system. If anybody happens to walk down Front Street across from the Metro Center in Toronto, you'll see this linear drain. I think it's at the corner of Peter and Front. Fantastic way of bringing stormwater into the tree planting zone, simple linear drain, easy to maintain, and very visually appealing. Now, just jumping forward, I'd like to give you an understanding of some low-impact development case studies. We're going to take a project here, which is in Chicago Navy Pier. Extremely high pedestrian space, very, very well known, and this is what it looked like before. Now, we're working with a company called James Corner Field Operations out of New York City. We redesigned the space, and here it is during the construction. We provided underground assets to support canopy infrastructure and tree planting on this structural slab at the Navy Pier. Now, this project is one of the first sites project in North America. Sites is the new extension of LEED for landscape architecture, the landscape architecture side. And when we move forward here, we can see 2 years later of this space. So if anybody does get to Chicago, make sure you visit the Chicago Navy Pier. It is a beautiful space, incredible tree canopy, and also being utilized for stormwater management at the same time. Now, just jumping forward, we're just going to jump across the world over to Cardiff in the UK. This project is Greener Grangetown. We can see this kind of desolate-looking street in the background there. Lots of vehicles, a lot of challenges, and a lot of complaints from the residents on the street for various things, but one of them being that it wasn't a very hospitable green space. So what we did here is we redesigned this to meet the requirements of what the actual residents wanted it. So I just want to highlight here, when we're creating spaces, it's always good to communicate. It's always good to speak with the surrounding residents and get an understanding of what the challenges they face and what they foresee. Treat them, as we say, as grown-ups. So one of the things we did here, we did some door knocking, we did some YouTube films, we did social media, we did what we call street surgeries. We got opinions and options, and we engaged for their support, which was priceless information for creating a successful project. So a very short period of time later, here we are at that same project in Greener Grangetown. And this is the same project that we are removing 98% of microplastics from the stormwater going through the system. And not only that, this project was an award-winning project for Retrofit Scheme of the Year 2020 SuDS Like Awards. And here it is. Isn't this a beautiful space? So if we take this vision and we take the little acorn that we saw in the first image back at the beginning of this presentation, and we start implementing it and designing it and creating the function and thinking about sustainability, we get projects like this. We're actually winning awards, but at the same time, we're benefiting the surrounding residents and spaces. Now, Greener Grangetown was an interesting project, but I'd like to go to a very, very challenging project. And this is here in Ontario. It's at the Thunder Bay Hospital. And in most instances, we have challenges, and turning a stormwater pond into a parking lot is simply not an option. But sometimes when we're using an engineered low-impact development system, it's not only possible, but it can be done with the added benefit of healthy trees. So here we are at the Thunder Bay Hospital, Thunder Bay, Ontario. Beautiful space And we took a storm pond and we changed it into a parking lot. I'd just like to show you during construction. Now, this is a very advanced low-impact development project here. But we can see here, this is the infrastructure that's below ground to support the stormwater attenuation, and then also support the tree planting above ground. So this raised area in the center of these plastic structures is actually the island within the parking lot where the tree planting is going. And then if we just jump forward here, we can see after and see that space. So we're taking a stormwater management pond and actually changing into a usable functional hardscape that allows for tree planting and stormwater management. So these are what we call high performance trees. Now, we'll take this even more advanced. We talked about hydrocarbons and pollutant reduction. Here's another project, North Street in the UK. This is what's below ground, folks. So as we can see, we're providing a lot of infrastructure for the tree planting, but this infrastructure is also supporting the stormwater management. Now, I'd like to show the pictures of what's happening below ground because once this is covered over, we actually don't know what's going on. So this really helps us in understanding what these benefits are and what these spaces actually do for us. And here we have the finished application above ground. So we've got some simple open planters, we've got some tree pit fencing around it, and here we have a rainfall event where we're infiltrating that stormwater into that space. So it could be from a curb cut, it could be from a linear drain, as I mentioned, it could be from a pervious surface. Lots of ways of infiltrating the stormwater into these spaces. I'm just going to bring us right close to home to a project in Toronto, and this is at the Berczy Park. This is, I think, the world famous dog park, downtown Toronto. A fantastic space. If you haven't been to it, check it out. It's got an amazing fountain designed by Claude Cormier out of Montreal. What we're doing here is we're taking the stormwater from the site to this linear drain, which is along the edge of the paving next to the sidewalk. You can see it cut in there. It's 100 millimeters long, 100 millimeters wide, and we're filtering that stormwater into the planting zone. And here we are a year later. Check out those trees. So these trees are high performance trees utilizing stormwater management and tree planting systems. Now just jumping down, I'd like to take you to another project which we probably mostly see in downtown Toronto at the Jack Layton Ferry Terminal. This project was a very, very high profile project. It's on a structure as well. A lot of challenges here, but we invested in infrastructure below ground to create the space, and we also incorporated low impact development at the same time. So what we see here, if you're walking on top of this surface, all you'll see is the tree planting zones with these beautiful maple trees and this linear drain on both sides of it's an actual roadway, it's designed for a road, taking the stormwater and filtrating it below ground. Now what we don't know is the actual results of this project. So I'd like to highlight this here. So if you're ever at the site, you can kind of, in your mind, put some numbers together. So at the Jack Layton Ferry Terminal, there's 19 trees to be planted. I believe the first 17 were planted already. They're in approximately 15,000 cubic feet or 425 cubic meters of rooting space, providing attenuation, so holding the water like a sponge, over 25,000 gallons or almost 100,000 liters of stormwater. This is reducing almost 100% of the runoff from the space to be utilized within this zone. Now just closing up here, and I know I've gone through a few of these slides very quickly, but I want us to remember something. We need to think about how we create space. And I showed this image before us here. And in 2008, this is what the streetscape looked like. And you can see the restaurant there behind the gray vehicle in the background. And if we look on the right-hand image there, and we look at 2019, I could pretty much guarantee you that no one ever thought we'd have a space like we see here. And we can see in the left-hand image, there's very few pedestrians. And we have a challenging pandemic that we're working through right now. And we need open spaces, and we need to change these spaces, and we need to start reevaluating what our streets actually mean. And that's what we did here on this project. And I'd just like to show you an image. I'm sorry the video doesn't work, but this video is on our website. Here's a picture of a street that we've closed off and made into a children's playground. So we can start seeing this is what's going to happen globally. We can start utilizing these trees, not just for urban spaces in the sense of pedestrian walkways, but also for playgrounds and supporting infrastructure in those spaces. We can also start understanding how we can infiltrate stormwater management. And I do recommend you jump on our website, check out this project. There is a great video that shows and goes through how it was created. So in finishing up here, we spoke about the acorn. We spoke about that idea, we spoke about that concept, and we asked what it grew from. I'd like to highlight here, folks, that we asked the same question today. And what did that acorn grow from? And here we have a tree in a space, you might say it's optimum growing zone, grown from an acorn. And we look at this tree and we say, what did we grow from? And this is our space. It's for you and me to create sustainable infrastructure. It's for you and me to understand the environment we're in. It's for you and me to recover, rebuild, renew, and reshape. It's for you and me to understand the future. And this is the great space that we're in. 2020 is a challenge, but coming out of a challenge can really create a vibrant community. And I've seen it happen many, many times. So I just want to finish here, folks, with saying it's not just a tree. Sustainable infrastructure starts in design, and that's our space. Thank you. And is there any time for questions, Andrew? Are we doing okay for time?
Yeah, I think, Bill, if you want to handle a couple questions, we probably have a bit of time. But that was great, Jeremy. Thank you very much.
You're welcome.
Yeah, thank you, Jeremy. It's a kind of urban magic, isn't it? It really is extraordinary. Intriguingly, we have a lot of students with us that work in the area of applied electronics and electrical technology. And one of the things you mentioned was it's difficult to know what's going on underground. And it would seem to me that there's perhaps a role for sensors and other forms of electronics to assist us in some way in that project. Do you see examples of that possibility?
Yes, that's actually a fantastic thing that you bring forward, Bill. Two things on that, actually. We just introduced a new project, functional product, where it's a charging station at a tree. So you can actually drive your electric vehicle up, and there's a charging station at the tree. That's one key thing. There's also another thing where we're doing with airflow. We're actually using airflow below ground to reduce pollution, and there's a tremendous amount of sensors, moisture sensors, pH sensors, pollutant sensors, heat sensors. I'll use the word data. There is an incredible amount of data that is taken from them. So absolutely, these spaces require data and research to produce results.
I would invite our students to fill in the question aspect of this inquiry, and I'm happy to take those questions and pass them on to Jeremy. Ranjan, I'm just wondering, do you have any questions, or I don't know if you can see me or not there. I don't know if you're still there.
I am still here. Thank you, Bill. No, I thank Jeremy for the talk. One of the nice things about this type of delivery modality is it'd be great to see everybody in a hall together. Between my remarks and Jeremy's talk, I actually shifted upstairs. I commuted upstairs to the kitchen because I was, for the very important reason of getting another cup of coffee. My wife and daughter were here, and they also got a lot out of it in terms of the fact that, we love trees, and, the concept we're going to walk away with is canopy interception. What a great term. So thank you for your talk, Jeremy. In terms of questions myself, none really popped to my mind immediately, but I think as Bill, as the questions start flowing, a few may come up, and I'll jump in and ask them at that point.
Not a problem. Jeremy used a term that many of our students may not be familiar with, phytoremediation. Could you just give us a quick capsule on what that term means?
Yeah, that's really good. Phytoremediation. Well, we can actually utilize, just to give you an idea, there's terms we use, polluted sites, contaminated sites, brownfields, area where there's some type of pollution either coming from the air or from the ground. And phytoremediation is the removal of pollutants through plant life in that sense. It can be through sunlight in the plant leaves, through transpiration, it can be through evapotranspiration, it can be through the roots taking it up. So we actually have a schedule or a breakdown of how different trees, root systems grow, how different plants' root systems grow. So some plants grow laterally for the root systems. Some of the roots grow deeper. Some are columnar in shape. And these all actually change the variables of how the product, hydrocarbons for instance, or nutrients or whatever, are taken up through the plant and removing those pollutants. So different species of plants, different species of trees take up different quantities of pollutants. So in phytoremediation, we're using plant life, we're using natural growing plants to remove pollutants. And also one way of actually, just in a simple term, my brother's a soil remediation chap. You can take soil and you can just load it in a pile that contaminated soil, and you can just turn it over, and sunlight will actually remove some of the pollutants within the soil. So in the sense, we're using plant life to increase the speed and also use it for those spaces as well. Does that help a bit with it? I won't get into the total science.
That was great. That's wonderful. Thanks for that, Jeremy. And again, just a reminder to our students, the Q&A aspect of this conversation is available. Please make use of it and send your questions. Now, given that our primary sponsor and a tremendous sponsor for this has been TD Insurance, you mentioned liability issues that can be associated with this type of green infrastructure. How are some of those issues being addressed with people like yourself on the design side and the application side, and with the insurance industry itself?
That's actually a great question. So I'm going to use a
two for two on great questions.
Yeah, you're doing really good. I'm going to use something so simple that, I mean, we probably don't even recognize it as a liability. So a lot of cities, and this, I'm going to use a lot of cities because Toronto has gotten away from this, but a lot of cities use these wood or metal spikes that come out of the ground to hold the trees in place. Everybody does it. We see it in our parks. We see it in our urban spaces. We see it in homes. Those are a massive liability. I know 5 cities right now that have litigation against them because a cyclist or a pedestrian has been injured by them not being maintained or not being removed. So a simple factor like a stake, where we have staking trees, that causes a liability because of the lack of maintenance or the lack of positioning or the lack of education, and I push education so much all over the world. Even a simple thing like a stake for a tree that we think is helping the tree can cause a liability to a pedestrian or a cyclist. So utilizing and researching what other options there are instead of using staking, and there's lots of them. There's lots of underground systems that hold trees in place that you don't even need staking, is one way of looking at that. If we look at simple storm ponds, a lot of storm ponds have to have a fence around them, and they say danger, do not enter, and so on and so forth. We don't want children playing, especially children playing in those spaces, or animals, because if there was a massive storm event, those storm ponds can fill almost instantly if they have a large amount of water being directed to them. So again, liabilities with that. So we look at education as a resource to reduce or prevent liabilities. So of course, TD Insurance would obviously link with the understanding of some of those challenges. Does that help with that, Bill?
Absolutely, what it says to us is that this isn't really an insurance problem. This is a design problem, and it's up to knowledgeable people to come up with solutions that make most sense in particular situations. You mentioned as well mosquitoes can congregate around ponds, and is there a way of dealing with those pesky little
Yeah, we have to be careful how we state things, but we sometimes call them Zika farms when we call them, when we see these storm ponds, just sitting water, just stagnant water. You might say a disaster. They smell, they're not clean, they're unsightly, they're, mosquito infestation. There's actually quite a few different ways. Number one is to keep them below ground, so have hardscape over top of them. Number two is where you actually have moving water. So it's not stagnant sitting in a storm pond, but actually moves into the storm pond. I didn't really get into infiltration, but infiltrates, recharges the groundwater, allows for the application of actually balancing the below ground ground source groundwater as well. So there's lots of ways to look at that.
Now, I did see a student quickly flash on with a question. I didn't quite read the entire thing, but it had to do with the coagulation of mud and other impediments that might impede the flow of water, shall we say, in a permeable surface or whatever. What kind of maintenance is required with some of these new initiatives?
That's actually a very good question. It's an important question because, as I mentioned, sustainable infrastructure starts in design, but it always has the idea of maintenance in mind. So you've got design at the start, maintenance in mind. Everything requires maintenance. Sustainable infrastructure is not typically something you put in the ground, you walk away, and it's still working exactly the same 40, 50 years later. So reduction of sediment. I'll take the word mud and change that to sediment because then that covers a huge spectrum, if that makes sense. So reduction of sediment is very important. So if you have a pervious surface, pervious concrete, pervious asphalt, pervious pavers, it must be cleaned to function properly. Or else what happens, you get sediment or mud on the top surface, it becomes a membrane, and you don't get any flow through. So it stops functioning, not good. Linear drains, great way to infiltrate and bring stormwater directly into areas. Again, they require maintenance. You remove the top, you clean that mud or sediment out. Curb inlets, where you bring it into a catch basin, for instance, are a great way to do this. Salt, so de-icing salts comes along with it. So we don't want to pump that to our trees because that can, or green space, because that can kill it. So having a valve or an overflow is very important. Those are easily maintained because they reduce that within the bottom sump of the catch basin. But very important question. What I highlight here is make sure we have a maintenance plan in place to make sure these sustainable infrastructure initiatives function continually.
Great. I often say these maintenance people are our life cycle guarantors of sustainability in many ways.